5% of your API requests are failing with connection refused to Redis. DNS resolution by name fails, but connecting by IP works. The root cause? You're on the default bridge network, which has no DNS for container names. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Docker networking deep dive. Docker networking is the system that connects containers to each other and to the outside world. It's built on Linux kernel primitives like network namespaces, virtual Ethernet pairs, bridges, and iptables. Each container gets its own isolated network stack, preventing port conflicts and providing security. Docker's container network model organizes networking into 3 abstractions: sandboxes, network namespaces, endpoints, veth pairs, and networks, bridges, or overlays. This pluggable architecture allows different drivers for different needs, and the same container can be on multiple networks simultaneously. Here's how to inspect the CNM objects. Use Docker Network ls to list networks, Docker Network Inspect to see endpoints and IPAM, and Docker Inspect to view a container's network settings. You can also use ncenter to enter the container's network namespace and see interfaces and routes directly. Bridge networking is the default driver. When a container starts, Docker creates a network namespace. A veth pair attaches the host end to a Linux bridge and assigns an IP. Containers on the same bridge communicate via L2 switching, no NAT involved. Use brctl show to see the Linux bridge, IP link, show type veth to list veth pairs, and ncenter to inspect the container's network namespace. These commands reveal the kernel primitives that Docker abstracts away. Docker's embedded DNS server at 127.0.0.11 resolves container names to IPs, but only on user-defined bridge networks. The default bridge does not use this DNS. It relies on the legacy etc. hosts approach. This is the root cause of most container connectivity failures. When using Docker Compose, if you don't define a network explicitly, Compose creates a default network for you named Project Default. This network is a user-defined bridge, so it does support DNS resolution, unlike the default bridge from Docker Run. However, relying on this implicit network can lead to confusion when scaling or when mixing Compose and manual containers. Always define networks explicitly in your Compose file for clarity and control. Define a custom network in Docker Compose, YML, to ensure all services are on the same user-defined bridge, enabling DNS resolution and isolation. This avoids the implicit default network and makes the configuration self-documenting. Overlay networks reduce the effective MTU to 1450 bytes due to VXLAN encapsulation. If your underlay network, e.g., cloud provider, already has a lower MTU, e.g., 1400, packets may be fragmented or dropped. Always verify the end-to-end MTU by running ping mdo s1472 target from inside a container on the overlay. Adjust the overlay MTU with optcom docker network driver. MTU equals 1400 if needed. To debug DNS, check etc/resolve. Conf inside the container, it should point to 127.0.0.11. Use enslookup to test resolution directly against the embedded DNS. If that works but the default resolver fails, the container is likely on the default bridge. Overlay networks extend Docker networking across hosts using VXLAN tunnels. They encapsulate layer 2 frames in UDP packets, adding overhead. Use them for simplicity in Swarm, but avoid for latency-critical workloads. Initialize Swarm, create an overlay network, and deploy services. The overlay network allows containers on different hosts to communicate by service name. Note the reduced MTU, 1450 instead of 1500, due to VXLAN overhead. macvlan assigns a MAC address to the container, making it appear as a physical device on the LAN. It's useful for legacy applications, but not supported on most cloud providers. Host networking removes all isolation for minimum latency. Create a macvlan network with the parent interface. The container gets an IP on the physical subnet. Note that host-to-container communication requires a shim interface. For host networking, just use network host, no isolation, but minimal latency. Docker automatically manages iptables rules for port publishing, network isolation, and outbound masquerading. These rules bypass UFWA and firewalled, creating a security gap. Use the Docker user chain for custom firewall rules. Use iptables commands to audit Docker's rules. The Docker user chain is where you add custom rules. Docker never modifies it. Add except rules before drop rules. Monitor rule count to avoid performance degradation. User-defined bridge networks provide isolation and DNS resolution. Create separate networks for different service tiers. Containers on different networks cannot ping each other unless explicitly connected. Create two networks and run containers on each. The web container cannot reach the database because they are on different networks. This isolation prevents a compromised front-end from accessing the database. Expose in a Docker file is just documentation. To make a port accessible from outside the host, you need p at runtime. Bind to 127001 for local host-only access. For intercontainer communication, use network-level routing, not published ports. The bad example exposes the container on all host interfaces. The better example binds to localhost only. The best approach uses an overlay network with no published ports. Service-to-service communication happens over the internal network. This is the same issue we highlighted at the start. Here's exactly why that happened. The team was using the default bridge network with the deprecated link flag. When they removed link, they relied on DNS, but the default bridge has no embedded DNS. The intermittent nature came from the application, sometimes using cached IPs and sometimes doing fresh lookups that failed. The fix was simple. Create a custom bridge network and connect all containers to it. This enables Docker's embedded DNS at 127.0.0.11, which resolves container names to IPs. The team also removed all link flags and updated connection strings to use service names. This is exactly the incident from the hook. When you run containers on the default bridge without specifying a network, they cannot resolve each other by name. The API containers DNS lookup for Redis fails, causing intermittent connection refused errors. This is the exact incident from the hook. Running containers on the default bridge without link or a custom network means DNS resolution fails. The API container cannot resolve Redis, causing intermittent connection refused errors. VXLAN encapsulation reduces the effective MTU to 1450. Applications that assume 1500 byte MTU may experience fragmentation or packet loss. Always test MTU-sensitive applications on overlay networks before production. macvlan requires promiscuous mode on the host NIC, which most cloud providers do not support. If you need containers on the physical network in the cloud, use a CNI plugin like Calico or Cilium instead. Docker's iptables rules bypass UFWA because they operate on the forward chain, not the input chain. A UFWA deny rule does not block traffic to published ports. Always add explicit drop rules in the Docker user chain for ports that should not be externally accessible. By default, P binds to 0000, meaning the port is accessible on all host interfaces, including public ones. Always specify the host IP, e.g., P127.0.0.1.8080 for development services. To debug networking issues, first verify both containers are on the same user-defined network. Test DNS resolution directly against the embedded DNS at 127.0.0.11. Check iptables rules for port publishing. Use Docker Network Inspect to see which containers are on a network. Let's run through some common interview questions. Why does the default bridge not support DNS? It predates the embedded DNS server, uses legacy etc. hosts. How does VXLAN encapsulation affect performance? Adds ~100-200 microS latency and reduces MTU to 1450. How to restrict access to a published port? Add rules in Docker user chain. Accept allowed IPs, drop others. And a few frequently asked questions. Why can't containers on default bridge resolve each other? No embedded DNS, only custom bridges have it. What is the latency overhead of bridge versus overlay? Bridge, ~10-50 micros, overlay, ~100-200 micros per packet. How to add custom firewall rules for Docker? Add them to the Docker user chain. Docker never modifies it. To recap, always use custom bridge networks for multi-container apps. The default bridge lacks DNS and isolation. Overlay networks add latency and reduce MTU. For firewall rules, use the Docker user chain. These practices will prevent the most common Docker networking failures. Ready to go deeper? Up next, Docker Containerization Explained 2026 Guide, then Docker in production, then cannot connect to Docker daemon, causes, fixes, and prevention. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.